Last topic in 4.3, the IPv6. This is also the protocol some of these network engineers thought more legit, addressing the IP address shortage problem, instead of using these controversial netboxes. And that is why we actually upgrade from version 4 to version 6. The approach is very straightforward, expanding the 32-bit IP address space to 128 bits long. So the main goal of having IPv6 is exactly this. There are two secondary goals. First is to speed up the processing or forwarding of the packets as they come into a router. So in the data plane, packets coming in really fast. If we could reduce the forwarding time, processing time, we made the transmission process as efficient as possible. Okay. So you'll see in IPv6, the header is also changed to try to reduce the forwarding time, the processing time. The secondary purpose, this. We want to add something so that we could label the packets, so we could separate a group of packets from other, and make them flows, different flows. Now, with the different flows of these packets, we could then assign priority to a specific flow versus lower priority for other flows. Okay. Therefore, we could establish a more flexible levels of quality of service for these different flows. Okay. You see also header fields there to support labeling of flows, setting priority of the flows. The IPv6 packet format. The header part of it is fixed size and 40 bytes long. Now recall version 4. Is it fixed size or variable size? It's actually variable size because of the option fields there. So that field, in case we have more options, then it's going to go longer. No fields, 0. And therefore, IPv4 header size is 20 bytes minimum and could potentially be more. Okay. Now you probably recall, right? When we were talking about the IP header size, 20 bytes, we also mentioned the TCP header, 20 more bytes. Together, 40 bytes, just to store the control information. If we're sending a real message that's 10 bytes long, the entire packet will be this long, while only 10 of them is effectively sending data. This is very low utilization. So Poly kind of promised you that in the next version of IP, we're going to reduce the size of the header. But you see here, is 40 longer or 20? 46 in fact has a longer header. But this is necessary, and this is as small, as short as possible already. Allow me to explain. In the IP packet header, there are two fields called the source IP and the destination IP. In version 4, the IP address space is only 4 bytes long. Now, to store source and destination IP, you only need 8 bytes. But in version 6, the main goal is to expand the IP address space. So unavoidably, we have very long IP address, and two of them, one for source IPs, another one for the destination IP, together 32 bytes. If you look at this, version 6 header 40 bytes, so we have only 8 bytes for the additional fields. While in version 4, 20 bytes long, we have 12 bytes for the additional fields. So the designer of IPv6, you see, try very hard to reduce these other unnecessary part of the header, removing them away, removing these fields away from the header. Okay. So 40 here, longer indeed, but it is actually after we try very hard making the header part as compact as possible, as small as possible. In fact, the second feature of the version 4 header is this. to recall in the fragmentation and reassembly function of IPv6, we have these three fields in a row: ID, fragmentation flag, and offset. This row of extra header fields remove entirely, okay, and this is done by disabling the fragmentation and reassembly function in version 4. So in IPv6, no longer allowing fragmentation. And this is why we see the version 4 header, although longer, it looks really clean and compact. Okay. First, the source address. Second, destination address. And the rest is only just 6 more. 1, 2, 3, 4, 5, 6. First, here is the payload length. If you recall in version 4, we do have what? The header length and the entire packet length. Because the header size can vary. And the packet size, because the data size can also be different, so we need 2 lengths. Here now, having a fixed packet header size, we need just the payload part, okay, the payload length to indicate the size of the data down here. Hop limit, this is just the TTL field, okay, just like in IPv4. Next header, it looks odd, we've never seen this before, but this is really the upper layer field in version 4. So what it does is, once we extract the payload, we actually forward the payload to what's indicated by this pointer here. And so further processing will be done using this handler on the payload. The version field. We also have this in version 4. So the only difference is that this value will always be 6 in version 6. Priority and flow label. These two are new. So flow label here is to allowing us to group a specific set of packets together. Okay, so coming from one application, coming from one service, they could be carrying flow ID 1, and other packets from other services, flow ID 2. So we could identify packets for one flow, okay, and packets for yet another flow. So we could separate these packets traveling the internet. As a result, we could then provide different priorities to different flows. So some flows will go earlier than the others. Therefore, we provide flexible levels of these QoS. Now, there are some more fields we remove, okay, not just the fragmentation fields. The header checksum in IPv4 header, that is removed because to calculate checksum takes time. To check the checksum takes also time. So let's try to reduce the forwarding processing time as much as we can. So let's remove the checksum part. And take the risk of some bits in the header being flipped. We might have some, we might run into some errors, but chance is very low. Okay. We way higher here, way more here, trying to make sure the forwarding part is fast. And we move the option part down to the payload, so that when we grab the payload and give it to the handler is going to look at the first few lines in the payload, and those will contain the options. Okay. There's one more thing. Icmp version 6. What is Icmp? You need to think back. In one of the earlier overview slides, I was talking about the functions and protocols implemented in the network layer, right? In the data plane, we have forwarding. In the control plane, we have routing and management. Icmp is one of these protocols implementing the management function. Okay. So we also extend the version 4 Icmp to version 6. Okay. And the reason we need the version 6 Icmp is so that we could send a special message, packet too big. Okay. Allow me to elaborate. Now we don't have fragmentation and reassembly. the fact that some of the links on the internet allows smaller MTU is still there. So what if we have big datagram coming to a router and the next link is saying MTU smaller, but we cannot fragment this datagram anymore? What should the router do? What can the router do? Okay, so the mechanism in version 6 is to send a special message, an Icmp version 6 message, back to the data source saying packet too big and the better packet size is below this MTU value. Okay, so there's additional message being defined in Icmp version 6, allowing the routers to manage themselves, deciding what is the best datagram size. And we'll just ignore this part. Multicast, we'll just not talk about it at all. Okay, it's a can of worms. So this is IPv6 packet format.